Yeah, good evening, everyone. Welcome to the session. So we will be continuing with domain analytics. Okay, let me just clear. Yeah. So we'll continue with our domain analytics program. So our topic at hand is hospital analytics. Okay. So we had seen the project management methodology, various applications relating to this field. Management applications. We had also seen various EDA and pre-processing steps involved in this hospital analysis. Okay, and as a part of this project management, we had seen the second step we can say. Okay, so we are moving on to the next step, which is data mining. Now, this data mining, under this we are having three kinds of learning. We are having supervised learning, unsupervised learning. We also have reinforcement learning. Okay, we'll be covering supervised and unsupervised learning. So today, that unsupervised learning. So let us see. Okay, specifically we will be working on K-means. So let's see. Okay, so today's agenda will be looking at unsupervised learning, various kinds of clustering, okay, and specifically K-means clustering, how it works, what are the advantages of K-means clustering, what are the limitations, what are the basic concepts of K-means we'll be seeing, and our use case. Okay, so this is the overall functioning or flow chart of unsupervised learning. Okay, so let us see how does this work unsupervised. So we start off with historical data. So we are given historical data, and unsupervised learning has unlabeled data. Okay, there is no labeling, or we don't know the output and input in this data. It is unlabeled data. Now this unlabeled data, okay, it follows a machine learning algorithm. So an ML algorithm, okay, we'll put this historical data under this ML algorithm, maybe clustering algorithm, association rules, okay, various unsupervised learning algorithm. Once we have got, okay, we'll be able to find the various rules and patterns, natural rules, it is known as natural rules or pattern in the data. Okay, so this is done using some similarity measure. We'll be discussing this. Okay, and we use this rules and patterns, okay, to predict on the new data to which cluster this belongs to, or to which group it belongs to. Okay, so if we look at this unsupervised learning, we basically have two things here: cluster analysis and dimension reduction. Okay, along with this, there are various other algorithms like association rules. Okay, network analysis, recommendation engine, text mining. Okay, all these methods are coming under unsupervised learning. Majorly, these two are considered. Okay, first is cluster analysis. So we are having hierarchical. K means is non-hierarchical clustering, also known as this partition-based clustering. Okay, non-hierarchical, hierarchical. Then we are having Gaussian mixture model, also density-based clustering. Okay, these are the four major clustering approaches we know. Okay, then we are having under dimension reduction, we are having PCA, principal component analysis. Okay, we are also having independent component analysis and factor analysis. Okay, also SVD. Okay, these are all coming under unsupervised learning, but specifically we'll be looking at K-means clustering. So what is unsupervised learning technique? So unsupervised learning is a machine learning technique in which the models are not having this training phase. There is no training phase. Okay, as there is no training phase, we call it unsupervised. There is no supervision phase. Okay, so instead the models, they will try to find hidden patterns and insights present in the data. Okay, natural patterns, you can say natural patterns in data. Okay, you can say this learning can be compared to human brain while it is learning new things. Okay, now this goal of this unsupervised learning is to find the underlying structure of the data set, group the data accordingly based on similarity measures, okay, and represent this data as a compressed format. Okay, means a single cluster. You can represent the whole data in forms of clusters. Okay, now this resultant groups or clusters will have low weight. Okay, so the major thing here is the optimization method. Okay, which is minimize variance. Okay, here the optimization use this minimization of variance. Okay, so you can see here we are having an unlabeled data. Using K means we can cluster them together. Okay, so this is the basic thing which happens in K means. So let us learn about K means clustering. Okay, so this K means clustering, it is a clustering algorithm. Also, it is a non-hierarchical. Or we also call it as partition based clustering technique. Okay, it is a partition based clustering technique. Here in K means clustering. Okay, our main aim is to group similar data points into clusters. Okay, now this allows us to cluster data into different groups and a convenient way to discover the categories of the groups in the unlabeled data sets as we saw in the previous slide. Okay, So you can see here unlabeled data. Using k-means, we can label the data according to their group property. Okay. So here there is no need for training like in supervised learning. Okay, here no training phase is there. Okay, this is a centroid based algorithm. Okay, where each cluster is associated with a centroid. The main aim of the algorithm is to minimize the sum of distances, or it is also known as squared sum of distances. Okay, so basically it is variance only. Okay, between the data point and the corresponding clusters. So each and every data point from its centroid, okay, we measure the distance, and our main objective is to minimize this distance. Okay, minimize sum of squared distances. Or in turn, you can say this is variance also. So how does this name k-means come about? K-means. So here k-means is, we call it k-means because we are having k centroids. We start off with k centroid points. Okay, and so as we go on clustering, the centroid, okay, the centroid value keeps on changing. Okay, so we should initialize k centroids, and each time this k centroid, so suppose we are having like this data points, and we need to cluster this. Suppose, so first step is to choose the number of clusters. How many number of clusters I want? Suppose I choose 2 clusters. So first of all, I'll choose the cluster points. Okay, then we'll do distance measure. So we'll measure each and every point from each and every cluster. Okay, each and every point is measured from each and every cluster. Once you know the shortest distance between a cluster and a point, once you find the shortest distance for the point which is closer to the centroid, okay, we will merge the 2 points into a single cluster now. Okay, we'll merge them into a single cluster. Once this is done, once we have merged the 2 data points into a single cluster, suppose this is the cluster, okay, we'll again find the centroid of these 2 data points. Okay, so we'll have a new centroid point. Once this new centroid is found, okay, this will be the centroid of this cluster. Similarly, for this cluster also, we'll find a new, we'll merge it with the closest point, and we'll find a new centroid. Once this is found, again we'll repeat the step. Okay, from this centroid we'll find the distance between all the remaining points. Okay, and again the same thing, the shortest point will be clustered. Again the centroid will be found out, new centroid, it will move a distance. Okay, and it keeps on going until we get convergence, or until there are no more points remaining on the this sample space. Okay, so let us see. So first of all, we'll have to initialize k centroids. First of all, we'll initialize k centroids, and for each sample in the set of samples, we'll have to assign. We'll have to assign the closest cluster k based on Euclidean distance. Okay, closest point to the cluster based on Euclidean distance. So basically, if we are having suppose data point like this, and we have chosen this as the cluster center, this as the cluster initial centroid. So the closest point to this cluster, centroid, will be merged together and will get a new cluster. Once this cluster is found, okay, we'll again calculate the arithmetic mean. Arithmetic mean of the two data points. This arithmetic mean will act as centroid. Okay, as the new centroid. Once we have found this, suppose this is the new centroid. Once we have found this, again we'll measure the Euclidean distance between all the points and this new centroid. Same for this case as well. Again, we'll find distance of this new centroid and other data points. Again, we'll merge the closest point. Again, we'll find the center, and this is a cycle which keeps on repeating. Okay. Now, for each cluster in the set of clusters, we'll have to recalculate the clustered centroid. So, arithmetic mean of all the data points we'll have to calculate, and that will be the new centroid. Okay. It is based on mean of all the samples in the cluster, means arithmetic mean. Okay. Once this is done, we'll have to repeat this same step again and again until we reach convergence. Okay, so we'll be talking about this. What are the criteria of convergence also? Okay, so here we'll have to determine the variance of each cluster. Okay, we'll have to find the variance of each cluster and sum them. Okay, this variance of each cluster, sum of variance of each cluster is known as sum of squared errors. Okay, so this sum of squared errors, this is the cost function we need to minimize. Okay, we need to minimize this function. So this is basically the variance of the whole cluster. We need to minimize this. Okay, and this, all the steps will be repeated again and again until we find a best model. Okay, so I'll tell you why this repetition is done. Okay. Okay, so let me tell you why this repetition is done. So as this is a minimization problem, in optimization problems, okay, suppose a minimization or a maximization problem. Suppose this is a minimization problem. There is a problem called local minimum. Okay, local minimum. So our main aim is to find the global minimum. But sometimes it so happens that we stumble upon this local minima. So let me just draw a figure and just show you. So we'll be having something like this, a minima point which is local. Okay, this is the global minima. The lowest point in a graph is the global minima. Okay, but if we start here and we move along this curve, we'll stumble upon this local minimum. Okay, and this algorithm will stop saying that it has found the minimum value. If this is the case, you will not be able to find the global minimum. Okay. To avoid this issue, okay, we initialize different centroid positions. Okay, maybe we'll start at here and we will be able to find the global minima. Okay, for that reason, we initialize this, cluster centroid positions at different positions. We try with different initializations and we try to get the best result out of this. Okay, we try to find the best result out of this. Okay, so this is how a K means clustering works. Okay, now how to decide the value of K? Okay, so we are saying initialize K centroid, but what should be the value of K? Okay, so value of K, there are various methods by which we can find the value of K. Okay, one of the age-old method is, okay, to take the root over of n by 2. Okay, where n is the number of records. Okay, but this is outdated technique. So it was working previously for small records. Okay, but with the advent of big data, okay, big data, this is no longer in use. Okay, this is one of the method which was being used. Another foolproof method is ask the subject matter expert, ask the SME. If SME has any information on how many clusters to prepare, you can start working on that also. Okay, but this will not always be given to you. Okay, the number of clusters will not be given to you directly. So you can also find it statistically using something known as scree plot. Or elbow curve. Okay, we can find this value of K using scree plot or elbow curve. So how does this work? Let us see. So scree plot or elbow curve, okay, we find the total within sum of squares. So what is this total within sum of squares? So suppose this is a cluster in which we are having centroid and these are all the data points. So within sum of squares will be the distance of all the data points from centroids. Sum of this will be within sum of squares. So square of all the distance. Okay. So this y minus y bar whole square, sum of this. Okay, so this is WSS within sum of square, and for every cluster, if we add all the values, it will be total within sum of squares. So we find the total within sum of squares for different values of K. Okay, maybe K equals to 2, 3, 4, 5. So number of clusters. For different value of K, we'll find the total within sum of squares and we'll find this. We'll draw this. We'll draw this plot K versus TWSS. Okay. Once we have got this plot, okay, we'll find the point at which an elbow-like or sudden change in, you can say sudden change in slope of When this is the case, when we are having a sudden change in flow, okay, we'll consider that k value as a significant k value. Okay, here because it is at this point that a change is occurring. So this is a significant. This is a significant k value. Okay. Once we have found this value out, okay, we'll use this k value. Okay, and we'll initialize that k value. Okay, so this is also one of the way by using within sum of squares and total within sum of squares and various k values. Okay, we are also having various other methods like silhouette method. Okay, we can also use within sum of squares and between sum of squares. Okay, various other methods are there to determine the value of k. Okay, once this is determined, the value of k is determined, we can go for this algorithm. So initially we'll find two centroid points. Okay, and then we'll keep on clustering the nearest most value based on Euclidean distance, and keep on changing the clusters, again repeating the same again and again. Okay, and this initialization also we can try with different initialization. How are we getting a better value with different initialization? Also we will check. If you are getting a better value, we'll take that initialization and we'll work on. Okay, now what are the various advantages of k-means cluster? Okay, so using this k-means clustering, we can first of all group unlabeled data into similar instances. Similar attributes can be grouped together. Okay, that is one of the things. So this we can also use the similar groups to do analytics on them. If we are finding similar groups, we can take this group as an individual data frame and we can do analytics on this. Okay, then we can also do. Okay, it is the most used clustering method. Okay, because of its ease of use and it being able to work with big data. Okay, large scale data. Okay, it can k-means can easily work with large amount of data. Okay, it can also scale well with large data. If you are having large amount of data, we can easily scale with k-means. K-means is also computationally very inexpensive. Okay, and it is an appropriate method when we know the number of clusters to be used. Okay, if you don't know the number of clusters, maybe go for hierarchical. If we know the number of clusters, k-means is the best method we can use. Okay, and lastly, it is having high speed, so it can work with a large amount of data with a very high speed. Okay, now what are the limitations of this k-means clustering? Let us know that also. Okay, so here we need to choose the number of clusters upfront. Okay, first we need to choose the value of k. Unless we know the value of k, we cannot go forward. Okay, and cluster. So if we choose a wrong value of k, we will get some value which will not make any sense. Okay, also as this is a central value method, as it uses a central value. Okay, centroid, as it uses a central value, centroid. Okay, it is greatly influenced by outliers. So if there are outliers in our data, we'll not get correct results because the centroids will be affected by this outliers. Okay, so outliers have strong influence on the results. So before doing this k-means clustering, we should remove this outliers. Okay. Also, initial centroid positions have a strong influence on the result. So if we initialize the centroids at wrong positions, we might end up getting a local minimum, as we discussed. Okay. So this is also an issue. And it doesn't cluster well with clusters of varying sizes of density. So if you are having two clusters of varying size and density, it will not perform well. Okay, in that case. So let us also discuss some of the key concepts on k-means clustering. Okay. So for stability of the k-means clustering, we should run this k-means algorithm multiple times with different or randomly chosen k values. Okay, so for which will change the total number of k values and will run multiple times. Okay, this will address the multiple local minima values. Okay, so if you are having local minima values, okay, running it multiple times may give us a global minimum. Okay. Also, there is an issue where a point might keep on oscillating, okay, between two clusters. The data point might keep on oscillating between two clusters indefinitely. Okay. So this can be stopped using convergence criteria. Either we will use a convergence criteria or will specify the maximum number of iterations. Okay, these we set as a parameter, maximum number of iterations, or will address a convergence criteria. Now this maximum number of iterations, so we'll say just total number of iterations will be taking 30, suppose. So it will iterate 30 times. Once this is done, whichever cluster this data point belongs to, it will be in that cluster. Okay. So that is maximum number of iteration. If we are specifying maximum number of iteration, it will work like this. Now, second is convergence criteria. So we'll define a criteria based on which this cluster centroid will either be in the first or second cluster. So this convergence criteria, we say that if the cluster centroid, okay, it moves less than a certain threshold value. It moves less than a certain threshold value. Okay, now this value is generally taken as a percentage of the smallest distance between two centroids. A percentage of this distance between two centroids. Okay, if the centroid moves below this, a certain percentage of this threshold value, okay, we'll say that, okay, the model of convergence. Okay, so this is also criteria. We'll set a criteria, something like this, convergence criteria. Okay. Also, we should be comparing between cluster variation and within cluster variation. Between cluster variation, okay, it should be as large as possible. Okay, meaning distance between two different clusters. It should be as large as possible. Okay, it should be as large as possible. This is between cluster variation. If we are talking about within cluster variation, okay, this should be as small as possible. Okay, this should be as small as possible. Also, as we discussed previously also, the objective function here is to minimize sum of squared errors. Okay. Main thing here is to minimize sum of squared errors, or we also call it as variance. Okay. We need to minimize the variance in k-means clustering. Okay, now let us talk about this use case. Okay, so as we are following hospital analytics, or we can say it as hospital administration analytics. Okay, so the administration side of hospital we are dealing with. Okay, so here we'll be dealing with clustering of nursing facilities. Okay, various nursing facilities will be clustering, and will be looking at various properties of these clusters. Okay, so we have taken this. This is a publicly available data set. Okay, it was created by Centers of Medicare and Medicaid Services. Okay, this data, it summarizes the utilization of payment for procedures, services, and prescription drugs provided by the Medicare beneficiary. Okay, to specific inpatient and outpatient in hospitals and various physicians and suppliers. Okay, so the Center of Medicare and Medicaid Services, CMS, okay, it uses a hierarchical condition category for risk evaluation. Okay, HCC risk adjustment model, it is known as. Okay, it uses this HCC to calculate the risks involved in each of these facilities. Okay, so in our data set, we'll be using around 29 key features, okay, to cluster this nursing facility. Okay, I'll show you all the key features which we have used. Okay, and this will also help identify the nursing facilities that has similar behavior or characteristics. Now, based on this characteristic, okay, we'll make the inferences on the following groups or clusters. Okay, so let us see what we have done here. So first of all, we have used this to find out where more number of clusters are there. Okay, so this here we cannot know the names of the states. I'll show you in the code. So this is basically Texas. This is I think it was some other state. Okay, so this was Texas. Texas had the highest facilities. Similarly, highest HCC score was in this. I think it is okay. We'll say in the code. Okay. And Texas also had higher score because there is higher number of nursing facilities. Okay, so this is the HCC score. First one is various nursing facilities present in different states. So total number of nursing facilities. So darker the color, more is the number of nursing facilities. You can see this color map also given. Okay. Lighter the color, less number of nursing facilities. Here also same, darker the color, more number of more score, HCC, more HCC average score, and lighter the color, less HCC score. Now, we also found out the various nursing facilities which has the maximum average HCC score. Okay, so we saw this doctor hospital of West Covina was one of them which had the highest value. Okay, and these are the 29 key features which we have used for clustering. Okay, so here we can see having total stays, distinct beneficiaries per provider. Okay, average length of stays. So how many days a person or a patient stays in the hospital? Okay, total SNF charge amount. So this is like you know, yeah, skilled nursing facility. Okay, SNF is skilled nursing facility. So how much do they charge? Skilled nursing facility. Okay, so total skilled nursing facility, Medicare allowed amount. So all the amounts in skilled medical facility, the average age of the patient, male beneficiaries, whether they are male, whether they are female, non-dual or dual beneficiaries, okay, white beneficiaries or black beneficiaries, average HCC score. Okay, so this hierarchical categorical score we are having. Percent of beneficiaries with atrial fibrillation. So atrial fibrillation is arrhythmia or irregular, heart rhythm. Okay, this is a disease. Percent of beneficiaries with asthma. Okay, so breathing disease, with cancer, with CHF. CHF is uh, congestive heart failure. Okay, so here heart doesn't pump blood. Okay, heart muscles, they do not work. Okay, they do not pump blood. So this is also a disease, heart related. And then we are having chronic kidney disease. So here, okay, slowly this kidney, okay, loses its functionality. Chronic kidney disease. Then we are having COPD, okay, which is chronic obstruction pulmonary disease. Basically a lung disease. Okay, in this, the lung swells up and it causes obstructed airflow for lung. Okay, then depression. So this is a mental disease. Then we are having diabetes, which is the most common disease. Okay. Then we are having hyperlipidemia. Okay. So in this, the blood has higher amount of fat, and this stores at in arteries. Okay, and it may cause choking of this artery. Okay. So basically, if you are having cholesterol in your blood, this is what happens. Then we are having IHD. Okay, IHD is ischemic heart disease. Okay, in this case, we are having narrowed arteries. So the arteries are narrowed down. Okay, so the blood cannot flow fast. Then we are having osteoporosis. Okay, rheumatoid arthritis and osteoarthritis. Arthritis basically. Okay, schizophrenia is related to again mental disease, and stroke. Various kinds of stroke we are having, brain, heart. Okay. So these are the various features which we have used for clustering of nursing facilities. So in this nursing facilities, these are the beneficiaries which are staying, or patients which are staying. Okay, these are the diseases these patients are having. Okay, so we had used K-means clustering, and we have clustered them into 4 different groups. Okay, so you can see group 1, these are the institutes or nursing facilities we are having. And cluster B, these are the various nursing facilities. So in cluster A, you can see we are having Sandstone Heights. Okay, the mechanic, will, nursing and rehab center, Gregory Wing of St. Andrews Village, village care center, okay, Windsor Mead of Williamsburg, okay, various nursing facilities, okay, we have it clustered into various groups. So 4 groups we have created, okay, and based on the properties, we have also seen the properties of various groups. So we'll be seeing this, okay, based on this HCC, based on total SNF charge, okay, based on district beneficiary, based on total SNF Medicare payment, okay. So let's see the coding part of. Okay, so we'll be doing this in Kaggle kernel because this is easier to connect to Google Cloud Platform. So we have connected with Google Cloud Platform and we'll be using BigQuery. Okay, so you can see we are using BigQuery. Okay, so basically we are using this Google Cloud database to get our data. Okay, the data is directly downloaded from Google database. So these are the various, facilities we are having. So these are the various places, and these many facilities are there. So according to state, we have first hotel. Okay. So now, if we see here, okay. So now, if we see here, California, Texas. Okay, these are the places where we are having highest number of facilities. Okay, so you can see inferences are mentioned. Texas and California are the only states in US having more than 1,000 facilities. So these are the only states having more than 1,000 facilities. All other states are having lower number of facilities. Now, Puerto Rico, Alaska are the states having low nursing facilities with 5 and 7 facilities respectively. And about 40% of the total states have less than 200 nursing facilities. Okay, so now let us also see this HCC, so which has the poorest HCC risk adjustment score. Okay, so this CMS, Center for Medicare and Medicaid Services, they use a hierarchical condition category risk adjustment model to calculate risk. Okay, so this model diagnoses this categories into similar conditions with similar cost pattern. Okay, so let us see which different states are having what kind of score. Let me just show you this one. Okay, so here we can see again Texas and California, they are having the highest average HCC score. Okay, along with various other states like Florida, Minnesota, Louisiana, New Jersey. Okay, all these have higher score. Okay, and the lowest average scoring are Montana, South Dakota, Wyoming. Okay, the middle one is like Wyoming, and also Puerto Rico. Okay, so you can see the various values and the state name as well. Okay, so we have used plot view. Okay, so this interactive plot to draw this interactive plot, we have used plot view. Okay, so this is the facilities with maximum average HCC score. Okay, so let me just skip ahead. Okay, there are many UDA we have done. Okay, so let's move ahead to. Okay, so you can see we have also done word cloud. We have also created word cloud as part of our review. So let's move on ahead to our modeling part. Okay. So clustering of nursing facilities that have similar behavior. So for this, we have used 29 key features as we already discussed. Okay, like total say, stays, beneficiaries, okay, different kind of beneficiaries, male beneficiaries, female beneficiaries, dual beneficiaries, non-dual beneficiaries, white beneficiaries, black beneficiaries, okay, and beneficiaries with different types of diseases. So we have also used these features, okay, to plot it, to find our cluster. So here we have taken, okay, using mutant trial method and running elbow method iteratively for various values of k. Okay, we have seen that with cluster size of 4, we are getting the best possible result. So we'll be using this 4 number of cluster. Okay, so the value of k we have initialized. So you can see before start of the k means clustering, we have initialized this value of k. Okay. So here we have used all those 29. So from BigQuery, we are following this. Okay, so you can see here we have used an SQL-like statement. Select these all from. Okay, yeah. Select this all from BigQuery public data CMS Medicare nursing facilities 2014. So 2014 nursing facilities from this data set here. We are taking all this feature, all these columns. Okay? And once that is we have downloaded, okay, we are storing it in X, and this X will be using for cluster. Okay, so you can see from sklearn cluster we are importing k means, and this k means we have initialized here, and we have used k means plus plus as our initialization. So let me also tell you about k means plus plus. Okay, how we use this initialization. Okay, so generally in k means initialization is done random. So any 2 data points could be made the starting centroid. Okay, but in k means plus plus, a point is chosen randomly, and the second point is chosen as the highest distance point from this first cluster, first centroid. Okay, whichever point has the highest distance, largest distance from this point, any other point having the largest distance, that will be chosen as the second centroid point. Okay, largest distance point. So we are using that as the k means plus plus, and we have also set the maximum iteration. So we have also done the hyperparameter tuning. Okay, so max iteration it will run for 300, or if it converges before that, it will run up to that, or max it will run up to 300 iterations. Okay, and a total initialization, k initialization will be 10, and we have also set a random state so that we do not lose our model. Okay, so that we can reproduce the results. Okay, so we have created this, and I am now grouping all the clusters, and I'm naming them, naming all the groups like cluster A, cluster B, cluster C, cluster D. Okay, so you can see these are all the facilities coming under cluster A. These are all the facilities coming under cluster B, cluster C, and cluster D. Now let's do analysis on these clusters. Okay, so when we did this analysis, you can see group A has the lowest risk score. Okay, so we can say this group A is the best facility available because it has the lowest risk score. Then we saw group C performs the worst. You can see, okay, it has the highest value in every other point. So total charge for a skilled nursing facility also group C, whichever nursing facilities are there. Okay, total charge is more, total Medicare payment is more. Distinct beneficiary mean group is also more. Okay, group C you can see risk is also more, not that much, but still it is more. Okay, then based on beneficiaries also, we try to find the result. Okay, so group A we can see is white beneficiary support scheme. Okay, so group A supports the most number of white beneficiaries and least amount of black beneficiaries. Okay, so from all this, okay, let's go to the inference part. Okay, and let's see the inference. So the characteristics of nursing facilities in group A, after all the analysis we have done, okay, we saw that it was one of the best performing nursing facilities group, okay, which has the lowest HCC risk score, lowest Medicare payment than any other group. Okay. Also, this group consists of nursing facilities having the lowest mean score of HCC score, which indicates that this nursing facilities might have performed or served better to maintain a healthy population. Okay. We also saw the average value of total skilled nursing facility charge in this group are the lowest. Okay. So total skilled nursing facility charge is also lower. Medicare payment was average value. Okay. And the mean value of this distinct beneficiary was 79. All of these values were low when we are comparing it with other facilities like for other clusters like Group B, Group C, and Group D. Here, but we saw one thing that the white beneficiary distribution was scattered over the lower side. Okay, and the mean of the curve was around 50, while the black distribution, black beneficiary distribution group contained very less amount of data. So this indicated that it is this facilities are serving more white population. Okay, and we saw that similar distribution behavior is shown by variables. Okay, like total stays and distinct beneficiary per provider. Okay, so here also we have seen better result. Now we are talking about group B. Okay, so group B is one of the group which has this HCC risk value is on the higher side. Okay, and here the white population beneficiaries are also scattered normally. Okay, so it is around 220 to 239. The mean is around that region. Okay, and the black population beneficiaries are much higher in this group than group A. So group A had very less black beneficiaries. Okay, but still it is on the lower side. If we compare with other, it is still on the lower side, but it is more than A. Now group C is one of in which the mean HCC value is not that higher, but mean total skilled nursing facility charge is the highest. So you can see it has the highest value for this case. Okay. And in the last group, Group D, we saw the average HCC score of nursing facilities was the highest among all the groups. Okay, so these were all the inferences we got from this. Okay. Okay, friends, so we are at the end of our session. Okay, so we have completed the K-means clustering as well with the use case. Okay. So we'll be closing off this session for now, and we'll be continuing this session on Monday next. Okay, and we'll be coming up with other supervised learning algorithms. So thank you everyone and have a good day. We'll meet again on Monday.